All right, this is 2013 number 4. I'd consider this a function analysis problem. So they've given us this graph here. Notice that the graph is of the derivative, okay? So it is of f prime, and they're telling us it's twice differentiable, so I know we're continuous and all that good stuff on this closed interval from 0 to 8, okay? It has horizontal tangent lines at 1, 3, and 5 there. And it is defined, and then it says, well, that's interesting. Usually they give you an initial condition, meaning f of 0 equals something. Here they're giving you your terminal position. This is where you end up, right? So there's your terminal, okay? Terminal position there, okay? So that's interesting. I got a feeling that's going to kind of throw a monkey wrench into something later, but as we were. All right, find all values of x on the open interval for which you have a local minimum, justify. Okay, again, we are given the derivative, and they're asking us about f. So I would say the best thing to do here is probably a sign chart. So I'll just kind of do it up here. So given the derivative, we want to know information about the original. So remember, on a sign chart, I'm concerned about the positivity of the derivative. So here my derivative is above the x-axis, and then it hits 0 at 1, but it still stays above the x-axis. So there still may be a critical value at 1, and then it hits the x-axis again at x equals 4, and at x equals, let's see, that's 5, so then at 6, okay? And so we end at 8, and again here we start at 0. So the positivity of the derivative, again, I'm above the x-axis, and I'm above, so it's positive, positive. And then once you get to x equals 4, then it goes below the x-axis, so your derivative is negative, it's below the x-axis, and then it's above the x-axis again. So that tells me the original graph was increasing, increasing, then decreasing, then increasing. It's asking me about a local minimum, so I guess this would be a relative min or a local min. Remember, they could use the word relative or local there. So my answer to part A, okay, remember a sign chart is not justification on the AP exam, so you have to write some sort of a statement. So I would say something like, because the derivative of x goes from negative to positive at x equals 6, x equals 6 is a local minimum. Okay? And that was just worth 1 point as I'm looking at the scoring guide right now. It was only worth 1 point. Your point breakdown is 1, 3, 2, 3. Okay? All right. So we've got that part for part A. I don't think that's too bad. Part B, okay, is asking me to determine the absolute minimum value of f on the closed interval. Justify your answer. So we're talking about the absolute minimum. So remember, absolute or the extrema, okay, so the absolute min, it has to occur at one of two places by definition. It has to occur, so absolute min occurs at critical value or endpoints, okay? So this is, we need to take into account the critical values and the endpoints. So the critical value that I would be concerned with, just from my sign chart up here, right? I'm not really concerned about these because these are going to be, that's a max, right? That's, nothing's going on there. So I'm really only need to consider f of 0, f of 8, and f of 6, okay? Those are the three that I would need to consider. And if you'll notice, the graph that they gave me was interesting because it actually gave me the areas under the curve. If you kind of look at it carefully, notice that they gave me the area, the area, the area, and the area there. So this is where I'm going to have to take into account that other strange piece of information that they gave me is this terminal. So the way that I would say in words is how I would kind of put it would be that your endpoint, okay, your endpoint, or your ending position really, is going to be equal to your starting position plus the amount traveled. And I just sometimes need to kind of write that down in words for myself, okay? So that isn't the only way that you could write this, but it made sense for me to write it this way in this case because of what they gave me. They gave me that terminal position. So I'd have something to the effect of, for 0, you'll have to look at the areas under the curves, right? So keep in mind that this area is 2 and then 6, so you've got a positive 8 plus 7 gives you 15 there, but then you have to subtract 3 because that's under the curve, okay? So you would have to kind of calculate that for each one of those to get your integrals for each of those. So for f of 0, that's your starting position. So again, the way that I think of it is kind of your ending position, which we know was 4, right, equals your starting position, that's f of 0, that's what I don't know, and then plus the amount traveled. Well, the amount traveled is the area from 0 to 8 of f of x there, okay? So I can get this by adding up all those areas. So the sum total of the areas gave me a 12. So really this is like 4 equals f of 0 plus 12. If you subtract 12 from each side, right, then you have negative 8. So we know that f of 0 equals negative 8, right, because negative 8 equals f of 0 that way. Okay, so a similar process for each of the following. You'll have to check that was your endpoint, and then f of 8 will be an endpoint, and so will f of 6. We know that f of 8 was 4 from the problem, right? F of 8 was 4, so this equals 4. So this is obviously the minimum of those two, and now I just need to check this final endpoint, f of 6. Okay, and for f of 6, right, I would think of that as where you started, so f of 0, plus how much you traveled from 0 to 6 of f of x there. So that would be negative 8 and then a plus 5, because you've got 2 plus 6 is 8 minus 3 from up here would be a 5. So that gives you a negative 3. So if they're asking you for the absolute minimum between negative 8, 4, and negative 3, your absolute minimum is going to be at f of 0, negative 8 would be the absolute min. Okay, so let's take a look then at part C. Part C says, on what open intervals is it concave down and increasing? So I'm looking for the overlap. I would do this again with a sign chart. We already know the intervals where it's increasing, from 0 to 4, well, from 0 to 1, union 1 to 4, and again from 6 to 8. And now we want to look at where it is also concave down. So I would take a look at the positivity of the second derivative. And since I'm looking for where it's concave down, I want to know where that's negative. So I'm looking at the slope of the given graph. So the slope of this graph is negative until it hits 1. Then it's positive until it hits x equals 3. Then negative all the way to 5. And then positive from 5 to 8. Okay, so to 8, then it is positive there. All right, so what that tells me is that this thing is concave down, then concave up, and down, and up. And again, my areas of concern are this part and this part here, because I want to know where it's concave down. So here, it's concave down from 0 to 1, and from 3 to 5. So I want to know where does this overlap with the positive sections of the first derivative. Again, to get these, I was looking at the slope of the given graph, because this graph is the derivative, so the second derivative would be the slope of this given graph. So the overlapping sections, right, from 0 to 1, okay, from 0 to 1, so my answer for part B would be 0 less than x less than 1, and then again from 3 to 5, so from 3 to 4 would also overlap, so 3 less than x less than 4. Okay, those would be my two overlapping sections. And again, you need to make some sort of comment. The sign chart is not enough. So you would say, because, right, on both of these, the first derivative is positive and I'm off there, and the second derivative is negative, so less than 0, okay? So that would get you your 2 points for part C. And lastly, on part D, what's it saying here? G is defined by this, okay? If f of 3 equals this, find the slope of the tangent line. There's those magic words again. Slope of the tangent line, my plan is take a derivative, plug in to get the slope, then use, point slope formula, but I'm not even asked for the whole line. I just need to ask for the slope of the tangent line. So I just need to take a derivative and then plug in. The trick here is taking this derivative. So the derivative is going to be 3f of x quantity squared times the derivative of the inside. That's a chain rule there. And now, once I have this, I need to plug in to get the slope, okay? So I would plug in 3, right? So add f of 3. So we're going to say g prime of 3, right? So g prime of 3, I shouldn't have an equal sign there. So g prime of 3 would then be 3, and then f of 3 quantity squared multiplied by f of 3. Okay, so be careful right here. F of 3, they gave me as negative 5/2, okay? So, f of 3, this one is the derivative of 3. Okay, sorry, I lost that tick mark. So f of 3 is negative 5/2. So negative 5/2 is this, but then I need to square it. So it becomes 3 times, that'd be 25 fourths, okay, so 25 fourths there, multiplied by the derivative at 3. So for that, you're just looking at the given graph. The derivative at x equals 3 is going to be 4. So then over here, I'm going to do a 4. So 4 times 3 gives me 12, right? So I've got 12 times 25 fourths. 4 goes into 12 3 times. 3 times 25 is 75. So that would be my final answer for part D. And again, that was worth 3 points. So I kind of had to squeeze it in there. Hopefully your handwriting's a little neater than that. But I got 75. And we did that in 12 and a half minutes. So hopefully you got everything for that. Have a great day.